I guess my first question is why did you choose a conical nose cone as opposed to, for example, a von Karman shape for your nose cone?
I can take that unless someone else on the team wants to. Okay, cool. So we chose a conical nose cone specifically because we have experience with them and they're supersonic. They perform better for supersonic and transonic flight. And because our rocket was simming supersonic, we figured that would be the best option. We've recently started looking into von Karman nose cones, but we aren't as familiar with their construction as we are conical. So we wanted to stick to our guns for the competition rocket and then maybe experiment more on the von Karman side of things in the future.
Okay, so it was familiarity with that system then? Was the primary driver? Okay.
Yeah, definitely.
Yep. Can you describe, and then my next question, can you describe the pilot chute that you use to inflate your main parachute, as well as the 30-inch chute that you use for your nose cone? I saw descriptions on both your drogue and your main, but I didn't see any sort of descriptions as to shape, manufacturer, etc. for either that pilot chute or your nose cone parachute.
For the nose cone, it was a chute from a like a lock 4-inch kit. So just kind of like a flat chute. For the pilot chute, on the main parachute, that was also just sort of like a flat parachute we've had around for a while. Probably about 12 inches in diameter, around that. Can't remember the exact dimension, but maybe we'll.
Okay, so those are both just flat nylon parachutes that you have. Okay,
yeah,
that makes sense. Oh, yep. So we got a couple of.
Yeah, I was gonna go ahead and start addressing Matt's question in the chat. As for the payload progress, because of COVID-19, there was many problems with getting together and working on the manufacturing side of the payload itself. We were able to construct a prototype to show that the Regalo glider form would sustain flight and would be controllable. But as for main payload production, it was very hindered by the restrictions in gathering and in order to produce its production. I'll let Tucker talk more about the active drag as he is the lead for that project.
So I assume you're asking about any data we got during the Kansas flight, and unfortunately, it was pretty obvious in hindsight, but the microcontroller that we were using to interface with everything else on the circuit board was just mounted using like breadboard pins. So it actually, during the boost phase, came off of the pins and lost connection with a lot of the sensors, which meant we didn't get any data from the flight. We've since fixed that issue simply by hot gluing it down. A very simple fix, but it's done the trick, and it's since flown on our specific active drag test rocket, and we have gotten data, so it is working great. We haven't done any flights with the pedals deploying and trying to modulate the ascent quite yet. We're still trying to gather data and figure out the best control method through simulations and whatnot. So no incredibly interesting data yet. Hopefully we have incredibly interesting data by the end of the summer or early next semester.
And just to echo what Tucker said regarding the active drag project, its flight in Kansas was the first flight of the fully integrated system. So it is still just getting off the ground, I guess you could say. But as he mentioned, we do have plans for many more flights this summer, and we recently did actually get a custom PCB manufactured that fits perfectly within the body of a standard 4-inch rocket, which is where we're beginning our actual system test set. So yeah, he's got it pulled up right there on his camera. So we definitely intend to get data very soon, potentially real flight data as early as the end of July.
Okay. One other question I had. What made you choose 624 for your shear pins? What made you choose 624 nylon screws as opposed to some of the more standard sizes?
So, and you're referring to the 4 larger screws specifically on the payload bay?
The 4. So in your report, the booster section of that's securing the drogue parachute bay to the booster section.
Oh, right. Yeah, my apologies. That was just, so we do a lot of experimental testing for our deployment systems.
Mm-hmm.
We find that needs, just the best way to collect data in regards to the feasibility of the system. And just in our testing, we determined that those were a good middle ground between strength, keeping the rocket secured, and both able to be deployed with our systems that we had. Just experimental testing on both rockets in the past and Mountain Mama.
Okay, so can you describe what those experimental testing that experimental testing that you performed is? I see you had your recovery ground tests here. Can you just describe what that looked like, both in terms of any pre-test calculations that you did and then the actual testing itself?
Yeah, for sure. So generally our methodology is we'll use just some basic formulas to calculate how much black powder we need based on the area to pressurize and, well, I guess the volume to pressurize, which includes obviously the diameter of the rocket and how much black powder to put in it. And we did the same for CO2, assuming ideal gas to get a baseline, and then effectively just increment it up from there until we get a satisfyingly energetic deployment. So as far as our ground tests went, I know we did a number of tests with CO2, especially since that was a system that was new to us. We ended up settling on a 35-gram charge, which both fit nicely in the rocket and provided a sufficiently energetic deployment system. And black powder was the same. We started with the ideal measurement and then increased until we had a satisfyingly energetic deployment. We did notice with CO2, even with the pretty large canisters, while it did deploy, it definitely didn't have quite as much kick as we would have liked it to, which we supplemented that by having a tertiary black powder charge for the drogue specifically, which I believe we did mention in the report, and that ended up doing well. But it was all just ground tests, and like I mentioned, we would start at the ideal value and then increase from there until we hit something that was satisfactory.
Okay. I see you've got good propulsion and pressure vessel testing. So with regards to the failure that you had during your flight test, what are the changes that you plan to make in order to fix the system that you had, fix the problems that you had with your deployment system?
Joey, you want to take that, or we'll both take it? Joey's our avionics lead, so between him and I, we can answer that. Joey, I'll take it first.
Yeah, I can take it. So I assume you're talking about our deployment system shutting off shortly after its deployment. And we are doing we're planning on doing some testing of different combinations of switches and how our avionics are mounted in our avionics bays, so that we can ensure that that doesn't happen again. We are pretty sure at this point that it is most likely the switch that caused the shutoff, but we're definitely working on coming up with a testing strategy so that we can test different ways of deployment to make sure that it doesn't happen again.
And in addition to that, we've also been in contact with Mr. Bidel Garby, who's the owner of Altus Metrum, which the two altimeters that had issues were telemegas, and we've been in talks with him on what may have caused the problem, including sending him the EEPROM data from the altimeter so he can kind of give us a diagnosis. As Joey mentioned, we do believe that it is an error with the switch momentarily losing contact under high acceleration. And again, our switches are just standard C&K push button switches. We've also been needing to reach out to C&K directly and asking if we can get some kind of a G rating on those. Our mentor had mentioned that they'd worked well in the past, and we determined that on smaller rockets, like I know I flew the similar switch on a 4-inch rocket for my L2 certification, and there were no problems. So this is definitely a first, having a push button switch respond that way. So obviously, if it is a switch, our main goal is to kind of get to the bottom of that, and then, as Joey mentioned, switch to a different system as far as arming goes and keeping them armed. But that's currently where we're at in the troubleshooting process.
Okay, and then I think my last question is so I guess first off, follow-up question. So what other what other switches are you looking at potentially using? Do you have specific things in mind, or are you still looking for other options right now?
Well, so in the past we've used key switch. Oh, sorry, Joe. Did you want to talk?
Yeah, you can go for it. I was going to just say exactly what you're saying. So.
Oh, okay, sorry, Joey. But so in the past, we've actually used key switches on our rockets, which have worked well in the past. But our goal with switching to push buttons is to give the rocket a sleeker, it's just a sleeker profile. Not having the keyholes sticking out would reduce drag. So the idea of a push button obviously would be to get rid of that and have better aerodynamic performance. So we're kind of at a crossroads here where, we don't want to go back to the key switches because that's the problem that we're trying to fix, but now we're having problems with push buttons. Current ways forward are looking into some kind of a screw switch design, which we believe could kind of be the best of both worlds, a nice mechanically sound system that also doesn't jut out into the airflow, or alternatively, maybe a higher quality or more expensive push button switch that's rated for higher Gs. Something else that we considered was initially, we used a double pull, double throw switch that actually had the altimeters enabled when the switch is in the depressed position, or well, not depressed, it's when it's sticking out. I can't think of the terminology for that. And the idea behind that was obviously, the spring is under tension, so, less stored energy. And what we thought was a lower likelihood of it disengaging. In hindsight, it's possible that having the spring not be in a locked position could have been what caused it to lose contact. So further tests are in order, especially trying to switch in the alternative configuration. Again, trying higher G-rated switches, which we'll see if that matters once we hear back from C&K, or something like a screw switch, a different way entirely.
One other thing we've been looking into has been building some sort of electronics bay testing apparatus so we can put just the electronics bay through a brief portion of high acceleration and have some sort of electronics inside that are able to tell if it loses continuity with the switch so that we can test many, many times and not have to prep a 30K rocket every single time we want to try something new.
Those all sound like excellent ideas and approaches. One other thing that I think I would recommend is potentially looking into having 2 dissimilar switches for your dissimilar redundant systems, so that if there is some sort of a systematic problem with one of your switches, it doesn't end up affecting the safety of your flight. And then there was one other question I had. Where did it go? There was another recovery related one. I think it was about your batteries. Yeah. So for your recovery system, you mentioned using a 9-volt battery for your Stratologger CF. So what did you guys, what specific brand did you guys use for that? Did you verify that the batteries that you're using are are welded cell batteries as opposed to ones that are just a press fit? Because I know that, especially with high acceleration flights, one of the problems that can happen with especially with cheap 9-volt batteries is that if they have just press fit cells, those can lose contact in flight, and those can cause power issues. So have you done any looking into that?
They were Energizer batteries. I know personally we bought a big pack of them a while ago, and we're just continuing using the same pack. We've never had an issue with the pack we're currently using. So we have a lot of batteries left in that pack. So it's been a non-issue for us.
I'd also like to add to that, with the Stratologger CF, one of the great things about that is possibly an oversight in the Telemega system is that it has a brownout capacitor, which may have been one of our saving graces with the previously mentioned switches, and why the Stratologgers didn't shut off and the Telemegas did, or the Telemega did. But that is also something with the 9-volt battery, the brownout capacitor is a little safety factor there.
And adding on to the welded versus press fit discussion, I would like to add, so soon after we flew for a test flight, we actually saw a post, I believe it was on the Truly Rocketry Facebook page of all places, where they were mentioning, that exact problem with 9 volts. And with that in mind, we've also been considering switching to lithium, to big LiPo batteries to fire our charges. The reason why we didn't do that for this test flight is, again, just because of experience. We've been using 9 volts, for all of our rockets, and this is the first time that we may have potentially had a problem with them. But definitely, we're looking into potentially using a LiPo, seeing if, the weight trade-off is worth it. And in the case of the Telemega, we did have to have a secondary, a lithium ion to actually power the flight computer. And if we could get one without current protection that could do pyros as well, that's something else that we're looking into. But we're recently, with the new altimeters, again, this is our first rocket to fly with Altus Metrum hardware. So we're in the process of potentially redoing our entire avionics system in the sense that, we're switching altimeter brands, power sources, switches. So it's definitely a time for development and testing. And we look forward to refining the system that we have.
Awesome, that sounds good. And yeah, I think that brownout capacitor feature on the Stratologgers is awesome, and I know it saved my butt a couple of times. So yeah, I would just recommend that if you're going to keep going with those 9 volts, you mentioned having a lot of them, it might be worthwhile to sacrifice one of them to the disassembly and testing apparatus to make sure that that's not a potential point of failure moving forward. So I think at this point we should probably call it for you guys, and so that we don't get too far behind schedule, and switch over to University of Maryland.